Absorption. This is the process by which the end products of digestion, that includes amino acids, glucose, fatty acids, and glycerol, process by which these end products are being absorbed into the blood or lymph vessels coming from the intestinal mucosa. So where does it actually take place? Absorption mainly takes place in the small intestine, although some amount of absorption takes place in the stomach and in the large intestine. But when we're thinking of absorption, we mostly focus our attention, or it mostly occurs in the small intestine. After the food is being absorbed, it will then be taken to all parts of the body, that includes all the cells, by the transport system. And the transport system in the body is blood. That's why we call it the transport system or the circulatory system. First part, absorption in the stomach. What is it that is being absorbed in the stomach? We have small amounts of glucose being absorbed. We have ions. We have ions of inorganic salts. And we have alcohol. These are being directly absorbed in the stomach. And that's why with alcohol, that is why when you drink a lot of alcohol, or when you drink alcohol, it doesn't take long before you start feeling dizzy or before you start feeling tipsy, because alcohol is absorbed in the stomach very quickly and it already flows all around your body to start making you feel tipsy. Otherwise, if alcohol was absorbed in the small intestine, it will take a little longer before you start getting tipsy from drinking alcohol. Absorption in the small intestine, we'll be looking at the three major components, or the three major breakdown products of the three food types. The first one here is glucose, or we're looking at monosaccharides. Glucose is absorbed by the villi. We saw the small finger-like structures that exist in the small intestine. We'll look at them again later. Glucose is absorbed by the villi against a concentration gradient. It means the absorption of glucose occurs through active transport because it's going against the amount of glucose. There's already too much glucose in the blood, yet more is coming from the intestinal mucosa. And because the body is always desperately in need of glucose, because that's our major source of energy, although there's too much already in the body will make sure that the excess that is available still has to be absorbed. That is why it would even rather use energy to force that extra amount of glucose into the bloodstream. Whether there's enough glucose or not, it will always be absorbed. If there's little glucose in the blood, then glucose will be absorbed by diffusion, by passive transport. But if we are looking here at the normal case scenario, where the person is undergoing proper nutrition, always has enough glucose in the body, and extra glucose is coming in, how will this glucose be absorbed? It will be absorbed now through active transport with the use of energy against a concentration gradient. The active transport will then involve the use of carrier molecules. These are the carrier molecules that will be involved in actively transporting the glucose from one side to the other, from where they are less in concentration to where they are already high in their concentration. And there are two paths through which substances can enter into the villi. It's either they enter into the lymph or the lactin, or they enter into the capillaries. Those will be the blood vessels. So glucose specifically enters the villi into the blood capillaries. Absorption of amino acids. The absorption of amino acids occurs just like how it occurs with glucose. It therefore means that amino acids are absorbed by the villi against the concentration gradient. It means by active transport. And carrier molecules will also then be involved in absorbing these amino acids. The amino acids will then enter the villi through the blood capillaries. Here are the blood capillaries, what you see here in circles. These are the blood capillaries of the villi. Remember, this whole structure here is one villus. Now, absorption of fatty acids and glycerol. One thing to remember or to note is that lipases or fats are not soluble in water. So water is the general solvent that's involved in dissolving substances in the body and then absorbing them or making them to get absorbed. Unfortunately, fats don't easily get dissolved in water. So that's why, if you remember, we learned about bile and bile salts. Bile salts will then first emulsify, make the fats to become droplets, will emulsify the fats so that the breakdown products, fatty acids and glycerol, could be more soluble in water. This is to facilitate their absorption. And the fatty acid and glycerol will then enter the villi for the first time now by diffusion. Remember, earlier we were only talking about active transport. They will enter the villi by diffusion and will be absorbed by the lacteals. Again, for the first time, for amino acids and glucose, we're looking at the capillaries. This time we are looking at the lacteal that's found at the core of the villus, which will then join up here to form the lymph vessel. That's where fat passes through when it gets absorbed. Absorption of vitamins. Remember, we have two categories of vitamins here. We have fat-soluble vitamins that can only dissolve in fat and not water, and we have water-soluble vitamins that are dissolvable only in water. So the fat-soluble vitamins, I told you how to remember them. ADEK, A-D-E-K. The fat-soluble vitamins are absorbed passively by diffusion. It means along a concentration gradient with no employment of energy. While the water-soluble vitamins, for example B and C, may either be absorbed passively, that is by diffusion, or actively by active transport, in this case using carrier molecules. Absorption of minerals. Mineral ions like sodium, potassium, magnesium, and calcium are also just absorbed either actively or passively, depending on how much is required or depending on how much is already available in the body. I'll explain. It means that if there's already so much sodium in the body and the body still needs sodium, then it means it will be absorbed actively. Contrarily, if there's little sodium in the body and there's sodium available for absorption, in that case, it will be absorbed passively with no need for energy. That's what it means. Water, about 90% of it is absorbed by osmosis in the small intestine. Remember, for water, in this case, we can't talk of diffusion because we're dealing with water molecules. Specifically, when we have water molecules, we don't speak of diffusion, we speak of osmosis, which occurs exactly as diffusion from regions of high concentration to regions of low concentration along a concentration gradient without the use of energy. So water is absorbed by osmosis, while some of the water, the remaining one of it, is absorbed through the large intestine, and that takes us to absorption in the large intestine. Remember again, most of the absorption occurs in the small intestine. That is why in the large intestine, only water and certain ions and vitamins are absorbed here. Now, the water which is absorbed in the large intestine is done so that it can cause feces to form and to become hardened, so that we don't always flush out watery feces. Otherwise, we'll be losing so much water and this will lead to dehydration. It could cause possible death. And that only happens when you have diarrhea.